Assalamu alaikum. Inshallah, today's our small session is about complex engineering problems that we are going to introduce. Complex engineering problem is now a requirement of program accreditation as per PEC. Previously, it was not given much attention, or it was not given much focus, but in about 2019 and 2020, Abbott actually modified its student outcomes to include complex engineering problems. And at the same time, in Washington Accord, they are also now started to giving importance to complex engineering problems as well. Okay, so they're in Washington Accord, they already have complex engineering problems within the within their statements of the student outcomes. But anyways, this lecture today is about how to include complex engineering problems. We're going to go start with the basics, okay, and we're going to go step by step in understanding all the terminologies associated with it. Okay, so the basic terminologies which the Washington Accord uses. Okay, let's first discuss about those. The first one is the one which we are most familiar is the graduate attributes. The graduate attributes are basically in our department the program learning outcomes. We have the mechatronic engineering program, and the outcome of that program is something that we want our graduates to have. Okay, so it's known as graduate attributes. Sometimes it is written as WA, sometimes it is written as GA. Okay, and within our program, we write it as program learning outcomes, PLO. So these are the basically 12 PLOs that we have in our program. Other than that, we have knowledge profile. Knowledge profile, there are certain knowledge profiles which are allocated by Washington Accord, and that should be present within the curriculum of the entire engineering program. Okay, so we are also going to discuss about that, and that knowledge is needed to actually specify the complex engineering problem and to select the courses where complex engineering problems can be employed. Okay, then we have complex engineering activities. Complex engineering activities are also included within the graduate attributes. Okay, and we have the most important are the complex problem solving attributes. Okay, they are written as WP. So these are the complex problem solving attributes. Engineering activities EA, WK is a work is a knowledge profile, and WA is the graduate attributes, which is also known as GA or PLOs. Okay. So the basic idea is that we have certain courses of basic nature, like for example, the physics, chemistry, mathematics courses, okay, some basics, drawing courses. These are the natural sciences that we have, okay. These are the natural sciences that we have, okay. Then these natural sciences becomes the basis for the fundamental engineering fundamental courses. So we have some engineering fundamental courses that becomes for which the basis are the natural sciences. Then once the students have gained some knowledge about engineering fundamentals, they can go a little specialized, a little expert knowledge. They can go for expert knowledge. So we have specialist knowledge courses. The courses where the specialist knowledge is involved. So basically the idea is that for the specialist knowledge courses, the prerequisite should be the fundamental engineering courses. And for the engineering fundamental courses, the prerequisite should be the natural sciences. Mathematics is involved throughout. So if you see, even within our mechatronics engineering program, in the 4 years, we have mathematics throughout going on from the year 1 till the year 4. Okay, so it will be there. So in working knowledge profiles, we have WK1 as the natural sciences. WK2 is the mathematic courses. Okay, so these two becomes the basis or the root for the other courses. Okay, then we have WK3 are the engineering fundamentals. Then we have WK4 as the specialist knowledge. Yes. Yeah, for this, I have also did a little analysis of mechatronics engineering courses, and I'm going to come over to that as well, okay, in the later slides. Okay. So then once you have the specialist, once the students have the specialist knowledge, now they are able to make some design. Okay, so then we have engineering design course where the engineering design is involved directly. Student is designing something. Okay, these are the courses which are termed as WK5, and obviously for the engineering design course, the prerequisite should be the specialist course. Okay, and engineering practice, normally engineering practice and engineering design goes side by side. Okay, so suppose if we have cases where a student is designing something in the course, but at the same time, there are some engineering norms, there are some engineering codes, standards, which the student is using to design. Okay, then WK6 and will be there along with WK5. Sometimes we have courses where the students is not looking into the fact that, okay, what is available in the market? Okay, what are the engineering codes, what are the standards? Then in that case, WK6 will not be there. But if he is still designing something, then WK5 will be there. Okay, so we have WK6 as the engineering practice. WK7 is the comprehension of the rate of engineering. So it's basically engineer and society, environmental constraints. These are the things which comes into WK7. Okay, and then WK8 is the literature research. Okay, where the students is asked to do some research. So he has to go through the literature material to look what is the up-to-date technology being used, and then he's actually trying to improve something over that or analyzing something over up-to-date standard knowledge. Okay, so that will come under the category of WK8. I don't know that whether in mechatronics engineering, if we have any course which actually comes under the category of WK8. When I try to go through the mechatronics engineering curriculum, I do not figure out. Yeah, not just writing down the paper, but you have to look at what has been done up to date. Yeah, but the thing is that for complex engineering problems specifically, FYP cannot be considered as a part of it. FYP is a separate thing. Okay, so complex engineering problems should be there in the core courses other than the capstone project. Okay, so anyways, so this is the knowledge profile. You can say the complete scenario picture. Okay, so we have natural sciences, mathematics. Okay, these are the base, and then from this we go for engineering fundamentals. Then from engineering fundamentals we go to specialist knowledge. Then if we have the specialist knowledge, we can go to engineering design, and then engineering design and practice most of the time they are together. Okay, but there is also possibility that engineering practice is not there if we are not asking the students or forcing the students to go through the engineering codes and standards which is used in the industry, or look at the available market, available material in the market. Okay, so then engineering practice will not be there. Otherwise, engineering practice and design both go together. WK7 is about the ethical issues, environmental issues, health issues, things like that. Okay, and WK8 is obviously the research literature. So this is basically the complete knowledge profile that we have that is specified by the Washington Accord. Okay. Now, this is a little description about, okay, whatever the slides I have taken from where I've also linked down the source from where I have taken those slides. Okay, so not all the slides are made by me. I've actually just researched the material from the internet and then put whatever I thought is relevant into the, okay. So we have WK1, natural sciences, WK1, mathematics and computing, okay, engineering fundamentals, WK3, engineering specialization, WK4, engineering design, WK5, engineering practice, WK6. There's a little description written, but I've already. For example, if we look at here for the case of mechatronics engineering, we can see different, because how I looked it is through the courses and their prerequisites. Okay, so statics is basically a fundamental sort of course. Okay, so that come under the category of WK3. Okay, so statics becomes the basis for the strength of material. Now, strength of material will then come under the category of a specialized course, which is WK4, and strength of material becomes the basis for the machine design. Okay, so the word design is basically important wherever the word design is coming. Normally what happens is that when the program evaluators come, so if they want to look at how the design course, how the faculty is teaching the design course and what are the parameters that the faculty is looking into account. So by just looking at the name of the courses where the design is coming, they pick those courses that, okay, we are going to look at how the design is taken into consideration. Okay, so machine design, for example, here it will come under the category of WK5 and WK6 if the engineering course and practices are also looked into it. Okay. Just WK5, WK6. So suppose if you are involving machine design in complex engineering problem, then you will consider machine design as WK5 because it is a high level. So you always consider go for the high level. Okay, this is the category of the course. Obviously, when it is a high level course, so it's understood that the low levels are already included into it. Okay, so this is one line. Then, for example, here if I see here, dynamics is basically a fundamental sort of course. Okay, then for the dynamics, we have dynamics becomes a prerequisite for theory of machines, which can come under the category of a specialized course. Vibrations, which can come under the category of a specialized course. Robotics, when I look at the robotics, it looks like there is some design element in the robotics course as well. Okay, so then that course would come under the category both WK4, WK5, WK6, depending upon if the engineering practice is involved, then it will directly come under the category of WK6. If engineering practice is not involved, just designing is done, then WK5 will be the level. But if even the design is not done and engineering practice not used, just some knowledge, specialized knowledge of the course material, then it will come under the category of WK4. Okay, this is just, we are specifying that if we are employing complex engineering problem in any course, which category does it belong to? Okay, and knowing that category is important because you have to mention that in the complex engineering problem statement as well. Okay, so we're going to come towards that, how the complex engineering problem statement should be there, in my opinion. Okay. Then when I look at the thermal side, thermodynamics is the fundamental course. Okay, which could be considered as a fundamental knowledge. Prerequisite, thermodynamics is a prerequisite of fluid mechanics, where fluid mechanics is a prerequisite of heat transfer, but in both heat transfer and fluid mechanics, we are not doing the designing. Okay, so designing aspect course is not there, and it is also not needed for the case of mechatronics engineering. But if complex engineering problem is placed in heat transfer or fluid mechanics, it will come under the category of WK4. Okay, and in thermodynamics, it might come under the category of WK3. No, it has to be at least WK3. WK1 and 2 cannot be. Natural sciences, mathematics, no way. Okay. Computing, yes. Look, the mathematics is basically a tool to solve engineering problems. Computing is also sometimes a tool to solve engineering problems. I was looking at a lecture, and this same question was asked about a course of MATLAB. Okay, so the presenter responded that if the course is about MATLAB, then that comes under the category of computing, and you cannot have complex engineering problem in that. But suppose if MATLAB is taught in a course as a tool, then in that course, complex engineering problem can be placed. Okay. So here, for example, this. Then I found one group here as well, like for example, electric circuit is a fundamental course. Okay, WK3, it will come under the category WK3. Electric circuit is a prerequisite of electronics devices and circuits, which will come under the category of a specialized course, WK4. And electronic devices and circuits will be the prerequisite, is a prerequisite of electronic circuit design and power electronics. I don't know if there is any designing done in power electronics or not. If there is no design element in power electronics, then power electronics at max come under the category of WK4, but it cannot come under the category of WK5 or WK6. Yes. Yes, it is dependent on, because if it is a design course, okay, and we are claiming it to be a design course, then the course outline will be checked that yes, is the course outline also depicting that this is a design course or not. Okay, if the course outline is saying that no, it is not a design course, you are not designing anything, but you have placed it in the design, that would become a problem. Okay, so the course outline is important, how it is placed. Okay, so here in that means power electronics will come under WK4. Okay, only electronic circuit design will come under WK5, and WK6 depends if there is engineering practice used in it or not. Okay. Then another group I found out was electric circuit is the WK3 fundamental course. Then there is network analysis, a prerequisite of network analysis, electric circuit. Okay, network analysis would be the specialized course. And then from network analysis, we have actuating system and instrumentation and measurement. Now, again, I do not know whether actuating system and instrumentation and measurement has any design component in them or not. If not, they will still be in WK4. But yes. No, right now we are not asking. We are not saying that which course has offered, which is not offered. Right now we are just specifying that which course come under what category. Okay, in terms of working knowledge, we're going to go towards complex engineering problems later on. Okay, so those who teach actuating systems and instrumentation and measurement, is there any design component into it? Do you teach anything related to design? No. So then in that case, instrumentation and measurement will still be there in WK4. It cannot become in WK5 or 6. What about actuating systems? No design component, huh? But no designing is done. No designing is done. That means I have written here wrong. It should both be in WK4. Okay. Then I found another one, for example, digital logic design. Digital logic, although here the course name is digital logic design, but it looks like this is a fundamental course because it's a prerequisite of all other courses, as I see. Okay, so I don't know whether this name is okay or not, but because the word design is coming in the course, and when the word design comes, it implies that this course is an advanced level course. Okay, no, so if it is not, it's okay. This is digital logic design. It is the fundamental course. Okay. Now it comes under the category of WK3. Then this is a prerequisite of microprocessor and microcontroller based systems, which might come under the category of WK4. Okay. And then this is my understanding, because this microprocessor and microcontroller based systems was a prerequisite of embedded system and manufacturing automation. So it should come under the category of design. But I don't know whether. So design problem is there. But the point is that whether it is elective or core, in the course outline or the thing that we teach, Okay, is there design element into it or not? Okay, okay. So this is just right now we are specifying which course come under the category of which knowledge profile. Okay. This how do we decide? Here another one, for example, control systems. There is no prerequisite of control system, right? No prerequisite, no need for any prerequisite. That means just the natural sciences would be the prerequisite in general case, if my understanding is correct. So in that case, control system would come under the category of WK3. Then we have digital control systems. Again, I placed it in the whole, but it depends that whether there is design element into it or not. If there is no design element, then the digital control system will only be there in the specialized category, WK4. Okay. Then I also see there is electromechanical systems. There is no prerequisite of electromechanical systems, although I think electric circuit should be the actuating systems. It's actuating. Okay, so okay, that's it. So because we have mechatronic system design. Now mechatronic system design should be the course of design. Okay, and it should be based on some specialized course. Okay, so actuating system is then the specialized course and mechatronic system design is the design course here. If engineering practice and the codes are used in the design, then it will come under the category of WK6. Yeah, but normally how we specified in our curriculum that this course, what is the prerequisite of this course, where we are looking in that terms. Yeah, this is what the practice is about. Okay, so this is just the allocation of different courses for different knowledge profiles, WKs. Okay, so let's come over to the relationship here. We have PLOs. Okay, as I told you, graduate attributes, which are basically GAs or WAs sometimes written. Basically, in Malaysian system, it is WA written. Okay, and here I have taken the slides from a Malaysian instructor, so that's why it is written WA. Otherwise, and some universities, they write it as GAs. And here, eventually, they are the PLOs. They are the program learning outcomes. And we have 12 program learning outcomes, very clear. The GS. The same thing. But then the relationship between PLO and graduate attribute is that we are offering a program, and the program learning outcome should be the attribute of our graduating students. This is the relationship. That we are offering a program, and the program learning outcome of our program, the program learning outcome should be the attributes which the student gain at the end of this program. So that's the relationship. So that's why they both are considered the same. Okay, so we have 12 GAs. Okay, we have the first one, engineering knowledge, then we have problem analysis, then we have design, development, then we have investigation and modern tools. Okay, so these 5 are basically the ones which are utilizing knowledge profile from 1 to 6. Okay, then we have the next 3, engineering, society, environment, sustainability, and ethics. Okay, so these 3 are basically the ones which are utilizing responsibilities of the graduates. So the graduate is responsible for the engineer and society, for the environment, sustainability, health issues, ethics. Okay, so these are the moral, ethical responsibilities of the students. Okay, so these graduate attributes relate to that. The above 5 are the ones which are actually the analysis of problems and synthesis of solution, where we are actually developing attribute of solving the problems and getting towards the solution for the students. And the last 4 are basically the ones which are related to the complex engineering activities, which are related to complex engineering activities, which are the teamwork, communication, project management. Here we don't have finance, communication, project management, and then we have the lifelong learning. Okay, so these are the ones which are required in the workplace. So let's say our students graduate and they go into the industry. So these are the attributes that the student should have, okay, in the workplace which he go to. So he should be able to work in a team, and he should have good communication skills. He should have skills that he can learn anything, whatever needed, lifelong learning. Okay, and he should have a good project management skills. Okay, so we have 4 PLOs which are related to the things required in the workplace. We have 3 PLOs which are about the responsibilities of the students, ethical, moral responsibilities towards the society in general. Okay, and then we have 5 PLOs which are related to the students' abilities of designing and getting the solutions of the problems. Okay, now the thing is that when we talk about complex problem solving or complex engineering problems, so complex engineering problems actually target this region. Okay, so this is actually not targeted by complex engineering problems. This is also not targeted by complex engineering problems, except for one activity, okay, which is the complex engineering activity as communication. Okay, that could be targeted because these are the problems for which the students might be asked to present, okay, and defend their solution. Okay, so in that case, communication becomes a complex engineering activity, EA. Okay, otherwise these 5 PLOs corresponds to, excluding WK7. WK7 was about ethics, was about responsibility, sustainability, things like that. Okay, except for WK7, from WK2 to WK6, sorry, WK2 to WK8. So it's basically WK1, sorry, WK3, 4, 5, 6, and 8. These are the 5 WKs which are actually targeted in the 5 PLOs. Okay. Practice. The idea is that if there is any engineering tool which is used as a standard engineering practice in industries, okay, and we are actually introducing the students to that, then that could be also related to the complex engineering problem attribute. Yeah, WK2.
So how do I manage WK2 or WK6?
Again, and this is a very good question, and that question also came to my mind when I was going through this exercise. And the only answer that I can come up with, which I do not know completely whether the answer is correct or not, if the course name specifies that this is just a course for software knowledge, then it will not come under the category where we can apply complex engineering problem. But if the course name specify that it is other than software knowledge, but you are using software in that knowledge, in that course, then you can specify. Now, this is the answer which I am giving, which I understand, and I'm not 100% sure that whether my answer is correct or not. Okay, because I am also gaining this knowledge from whatever the material was there on the internet. So there was no tutor.
in mathematics course, there is modeling engineering. So that is.
No, no, no,
Mathematics.
mathematics, you cannot, you can, yeah, but we cannot use, mathematics course is straight away, we cannot use complex engineering problems inside that. Okay. So it will come under the category of WK2. So here, this is important, okay? So we have what are the PLOs, which we will be addressing for complex problem solving attributes, okay? So let's move. As a complex engineering, okay, CEP is a complex engineering problem that might include complex engineering problem attributes and complex engineering activities.
If I want to ask, if I want to give you a problem, you want to design. Okay, let's say this is the problem. Then I ask them to present it.
And when they will be presenting it, they will be defending their work. Okay.
First, at the same time, I also ask them to see how will you conduct your, let's say, how will you present staff.
Yeah.
They will give some guidelines, some plans. In that case, I just think these are the problems that I invented to these problems.
For this, I'm not very sure, literally. I'm not really very sure about this answer. Okay. So anyways, so this is the relationship between GAWA and WK, which is the knowledge profile. WP is a complex problem solving attribute. Okay, and EA is a complex engineering activity. Okay. Okay, so now let's talk about the complex problem solving attributes, which are important for the complex engineering problems. Okay, so this site from where, for this source from where I've got this information, it lists down that there are 7 complex engineering problem attributes. Okay, the first one is the depth of knowledge, which is WP1. Okay, then we have range of conflicting requirements, then we have depth of analysis required, we have familiarity of issues, we have extent of applicable codes, extent of stakeholder involvement in the level of conflicting requirements, and interdependence. We're going to discuss one by one everything. Let's have a small break. Okay, now let's talk about depth of knowledge. Now it is specified that for WP1 is a must. So for in any complex engineering problem, it is important that WP1 attribute should be there. And WP1 attribute is specified that it should be composed of a course with the knowledge profile 3, 4, 5, 6, or 8. So if we have a course which comes under the category of knowledge profile 3, means fundamental course. If it is a fundamental, no, that means natural sciences are out. That means computing courses, pure computing courses are out. That means mathematics is out. Social sciences are out. Islamiyat is out. Pakistan studies is out. Okay. So if we have a course of fundamental engineering knowledge, that is WK3, then CEP can be placed in that course. If we have a course of specialized knowledge that come under the category of WK4, then CEP can be placed in that course. If we have a course where the design and engineering practice is involved, WK5, WK6, then CEP can be placed in that course. If we have a course where we have literature search, okay, where the WK8 is there, okay, then in that course also we can have complex engineering problems.
And find the scope of the art and do the area. Based on their like paper, basically has complex disease problem, in that case, it will be the WP is
No, this task cannot be assigned a as a complex engineering problem, but that course where we are going through the literature search, in that course we can assign a complex engineering problem. But complex engineering problem has complex problem solving attributes, and there are a set of attributes we have to include that in the complex engineering problem. Okay. So that must be there. But right now, this is just the assigning of which course is suitable to have complex engineering problem in it. Right now, this is about that. Engineering practice, workshop practice. For this, actually, I'm not pretty much confident about that.
Basically also practice is more of
Yes. When I'm saying engineering practice, it does not mean the hands-on practice that you're doing in the lab.
The way they are doing things are good, either mechanically or electrically. For last time, they have to run the board by any mechanical without any electrical component.
So do they have to do a lot of calculations into it, and they have to show that? But the calculations is a must here now. Okay, we're gonna come over to the attributes. At least 3 attributes are required. Out of these 7, at least 3 attributes are required, and we're gonna come to it one by one. Okay. Yeah, it's like WP1 is a must, but then from WP2 to WP7, at least 2. At least 2. Okay. Now this is from this Malaysian source. Okay. Now if there was another source of basically some Pakistani researcher. He was from UT Lahore, I guess. He had a video on the YouTube. Okay. When I go through that, he mentioned a presentation by PEC regarding that. Okay. In that, he also mentioned that other than this WP1 to WP7, there are 2 more. Yeah, this is EP1 and EP2. EP1, what he said is about consequences, high significant consequences in a range of contexts. And the example that he gave is that you want the students to generate power, but you do not specify which methodology he should use to generate power. Now the student have to think himself, if I use the diesel engine, I will be producing pollution. So whether use renewable energy, so the larger environmental context is taken into consideration or not. Okay, so this was the example that he gave, and he said that EP1 and EP2 are the ones for the high level courses. Okay, so they probably be the senior level courses. Okay, engineering practice. EP stands for engineering practice, so it's EP1, EP2. But the problem is that I personally would not prefer to go for EP1 and EP2 in complex engineering problem, because it's not just that you place a complex problem solving attribute in your CEP, you also have to justify its assessment. And that justification of assessment will become a headache. Okay, if you don't have a clear picture of the judgment of assessment, yes, if suppose you have a very clear picture how you're going to judge or assess this attribute, then it's okay. If you can justify it to that, because it's not just saying that, okay, I'm going to put WP1, WP3, WP7. No, you did. There has to be a specific assessment criteria that needs to be followed. Okay. And obviously they are going to check that whether we looked into account those criteria or not in order to justify the assessment. Okay. I'm saying that one student satisfied this attribute EP1. I'm saying other student did not satisfy the attribute. Satisfy this attribute. So one student, I say, okay, I'm giving him 50%, that 50% he satisfied this attribute. So what is the criteria? Okay, so that needs to be very clear. Okay, so regarding EP1 and EP2, things are not clear to me myself. I mean, I'm not pretty much sure about that as well. So I would prefer that if it is clear to you, then you include it in your CP, otherwise avoid it, because it is given as an option. Okay, so you have from WP1 till WP7 and EP1 and EP2. And you have to take minimum 3. At least 3 should be there, including WP1. So other than WP1, from WP2 to WP7 and EP1 and EP2, you have to take 2. This is what, how do I know? This is by the presentation of both the presenters whose videos I watched and the link I have provided. Okay, so they specifically mentioned that 3 WPs are 3 attributes are needed, out of which first is the WP1, then 2 more. But there is no limit. If a faculty wants that I want to put 5 attributes in this CEP, that's okay. He's allowed. If you want to put all attributes, it's okay. But he has to justify each one of them. And that justification become a headache. So why to increase the headache on yourself? Okay, well, so go for the minimum. Okay. No. Look, for the course to have CEP, first of all, course is not CEP. Course can have CEP. For a course to have CEP, it should be, yeah, WK3, K4, K5, K6. I'm not relating it directly to PLOs. I'm relating it to knowledge profiles. Okay. You can relate it to PLOs as well, because you see here, they have also mentioned that PLO1 is actually covering knowledge profile 1 to 4. PLO2 is covering knowledge profile 1 to 4. PLO3 is covering knowledge profile WK5. Okay, PLO4 is covering knowledge profile WK8. And PLO5 is knowledge profile WK6. But again, this is relative. This is not the definition by PEC. This is not the definition by Washington Accord. This is what the guy from the Malaysian University, when he was presenting, he did it on his own. Okay, so the broader definition is that basic knowledge, basic engineering core knowledge, fundamentals, specialized knowledge, design, practice. Okay. अभी इसको उधर रखिए टेबल पर Okay, so there was a paper in which was also discussed in the presentation of this Malaysian presenter, okay, Malaysian University. So he mentioned that the characteristics of a complex engineering problem is that it should be difficult to the solve. अभी करेंगे one by one करेंगे. मैंने हर एक की अलग स्लाइड बनाई है, ठीक है ना? Okay, so we have it should be something which is difficult to the solver, unfamiliar to the solver, has a number of variables and parameters, is connected to a few parts of a system or a few different systems. The solver does not have immediate solution to the problem. The solver needs to define the problem prior to solving it. The solver needs to develop his or her justification for the solution. The thing is that students, it make it difficult for the student. The student should work hard. The student should go deep in the course. This is the idea. It should not be something that the student can do it readily. Okay, he has to go through a lot of steps to solve the problem. Okay, we're going to go to the complex engineering problem attributes one by one. Okay, now WP1, depth of knowledge required. Okay, CEP should be composed of multiple solution modules. I mean, it should be a problem which could not be solved by just one set of calculations. You need to do one set of calculations to get an answer, which will be used in the other set of calculations, which will be used in a third set of calculations. So there should be a lot of calculations into it with a lot of variables. So this is a must, okay? So you cannot have a complex engineering problem without large set of calculations, okay? So just solving a single equation or using a single law should not be sufficient for solving complex engineering problem. Complex engineering problem should involve sufficiently large number of variables. It should have large number of variables, right? For example, normally when we are teaching a course, by the end of the course, we reach to the point that we can actually use a lot of laws and a lot of equations all throughout, which we have learned from the very first lecture till that lecture in one complex problem. So this is the idea, that the problem should not be, yes, yeah.
For example, lab PCB, the complex problem for a project that's given. So they don't go through multiple calculations while we have project.
No, but calculations is a must.
That
No.
what is the more in the front of simply designing of the project as a robot size that means to not exceed the battery that will be.
Yeah, but is there any calculation procedure through which they come to that design? I think this will be a problem. Large set of calculations are needed. And that is one of the reasons why I feel, this is my personal intuition, that complex engineering problems should be there in the theory courses rather than the lab courses. This is one of the reasons, okay? But this is my personal opinion and I might be wrong, but I have an example from one of the university in Karachi. But then calculations are needed. So we cannot say that, okay, he come over to the design without showing any calculations. And so large number of variables and large set of calculations should be there. Like, for example, if I talk in thermodynamics or heat transfer, I know that by the end of the course, we have a large number of variables and set of calculations for designing, okay, starting from the scratch till the end. If I just design, let's say, a heat exchanger, so that by the end of the design of the heat exchangers, just the calculation, the numerical calculation would be like more than 10, 12 pages. I mean, and I guess this is the same for the case of all the courses where the design is involved, where we are going in depth knowledge, okay? So this is the thing, it says depth of knowledge is required. Depth of knowledge means not just like you solve one equation, two equation, and that's the end, okay? So it has to be large number.
Not all
No. The depth of knowledge, look, okay, he got this knowledge in theory, but he has to, in the report, he has to show the calculations, how we come up with this solution, okay? And the calculation should be large. It should be huge set of equations and getting out the solution, okay? Things like that.
My understanding was that if I were to ask them to do independent planning, because there is not been thought that this is possible, and they are taking great responsibility to talk to them, to go to that, but then they can go away and do their independent planning, and then we will have the permission to come up with a solution. So that was something that I was thinking.
This is not necessary. Not necessary, but calculations should be there. Okay. So if for example, my understanding so far is that if an evaluator come and he see the report of complex engineering problem and he does not find any calculations in it. He have very little calculations, maybe 1 page, half page calculation, that will be kind of a violation of WP1, that depth of knowledge was not used. Yeah, we will discuss about this. I will give my opinion, and then obviously it will be the decision of the department. Okay. So this is about WP1, depth of knowledge required. Okay. And WP1 also specifies that which courses are allowed to have CEP, which courses are allowed to have CEP. Okay, so this is also specified, and it is specified that it should have large number of calculations. Then we move over to WP2. Okay, now WP2 is range of conflicting requirements. Range of conflicting requirements is that you have placed a problem where there are multiple options of solutions. Like, for example, the size is not defined, like voltage requirements not specified, weight of the product not defined. You're going to increase one thing, it's going to affect the other things. Okay, so maybe some student has made a selection of weight this much, so their design specifications are going to change. Their design, the product is going to change correspondingly. Okay, material selection is not specified. For example, battery size is not specified, charging discharging period not just specified, costs not specified. Okay, so you have open-ended things in it. Okay, and they are conflicting. You increase something, it's going to have an effect over the other thing. Okay, so maybe for example, if we talk about an example of a mosquito sweater, you know, the racket, mosquito electric racket, I can increase the size of the span of the racket, but it will become heavy, it will become more costly, maybe not easy to use. Okay, but it might catch large number of mosquitoes, comparatively easy. So there are conflicting requirements. Okay, so the conflicting requirements, if the conflicting requirements are there, then WP2 is the complex engineering problem attribute which is there in the CEP. Okay. Yes, open-ended. This is open-ended. This attribute is basically the open-endedness of the problem. But the thing is that here one thing the student have to focus in their report, and they have to mention that because of increasing of this thing, it affects the other thing. Short, so or because I increase that thing, it affects this thing. Okay, so things are affecting because of the conflict is there. Okay, because the things are interdependent. I mean, they are not separate. All things are not separate. They are interdependent. You're changing one thing, and the other parameters of the design are changing. Okay, and they have to mention that in the report. Normally, you can say size should not exceed this. You cannot say size should be this. You say size should not exceed this. Now they have an option. They can go for much smaller. They can go for even much smaller. Okay. So yes, you can define constraint, but you cannot tell the size. Okay. So this is range of conflicting requirements, WP2. Right? Okay, let's go to the next attribute, depth of analysis required. What they say is that it should not be a problem available in textbook or reference materials. There must not be a singular solution to the problem. Multiple solutions are possible for the same problem. I mean, it should not be something which is there in the textbook and the student have readily the solution available with them, or they can get it directly from the internet or some reference material. So if WP3 is there, it should be something which could have multiple solutions. Okay, one of the example given by one of the presenter was that if you have an electric circuit, large electric circuit, and you specify that, okay, these are the two resistors that you can put in parallel, and one resistor, now you have to decide yourself how it should be such that the current does not exceed this thing in one of the circuit, and the specifications like that, you can say. And now the students have multiple options. He can do like this, he can go like that, he can go with this arrangement, he can go with the other arrangement. So not a single solution. The important thing for depth of analysis required WP3 is that there must not be a singular solution to the problem. The problem can have multiple solutions, and there must be different solutions, and the students go through a specific analysis procedure and they justify, okay, which solution they have adopted and why they have adopted that. Okay, So this is WP3. Okay. WP4, familiarity of issues. The problem must have issues that are unfamiliar. Solution could not be found directly in the literature. Now, this is a problem because when I look at WP3 and WP4, it looks like they both are same. Okay? So, when I look a little more deep and in one of the paper, okay, I found this as an example. It was written that this means that it is possible to have a CEP with a singular solution, but the problem is self-developed, so the solution is not present in literature. In WP3, it should not have a singular solution. So WP4 means you can give a problem which has one solution only, but this is a self-made problem and it is not present in the literature, in textbook, in reference, on internet, anywhere. It is something related to your course and it is self-made, and so it is something that it has one solution only. Yeah, so it is not there anywhere and students have to work through themselves. Okay, so a CEP with WP4 and without WP3. But WP3 was that there should be multiple solutions. So there is a possibility. Yes. We can either have WP3 or WP4. This is what my understanding so far I got from. The main idea is that students are forced to determine the solution on their own for CEP rather than looking into literature. Okay. Students are forced to look for a solution.
Product management is the material specific, and then eventually make them quantity specific. You get one.
True.
Eventually find out what is the right method for that.
That's I think that perfectly fits into the example. So WP4 attribute is comparatively clear, but again, there are overlappings. Literally speaking, when going through this material, I got like really confused that how to find out the difference between them. Okay, now let's move to WP5. It says that extent of applicable codes. For professional problems, standard engineering codes and practice cannot provide the solution to the problem. That means it is not something that engineering practice can solve. Okay, you need a solution. Okay, for example, I need water to be pumped to a specific height. I go to market. Okay, engineering practice is that if your tank size is this much, take this motor. Okay, no direct solution. No engineering code or practice is there for that specific problem which you are giving, then in that case, it will come under the category of WP5. Normally, engineering practice and codes are such that you don't need to go through the calculations. You directly apply that engineering practice. Okay, so if we have a situation where if you go to the market that, okay, or if you go to the literature and I have this set of specifications, is there any standard procedure or standard thing for engineering standard for this, and you don't find it, now you have to go through the calculation step by step. You cannot rely on the engineering standards or codes of practice because the problem is beyond that. Okay, so for professional problems, standard engineering codes and practices cannot provide the solution to the problem. Standard engineering codes and practices are applied for a specific range of variables. Normally, they have a specific range of variables for which standard codes and practices are there. CEP should be outside this range. If WP5 is there, then CEP should be outside this range so that the students are forced to make calculations rather than relying on standards. This is WP5. Okay. While I am explaining you all the complex engineering problem attributes, keep that in mind. These are the attributes. You don't have to add all the attributes in your complex engineering problem. Okay, maximum 3 attributes are enough. Okay, sorry, minimum 3 attributes are enough. But maximum you can go through. You can actually use all of them. First one is mandatory. WP1 is mandatory. That means you cannot have a CEP without a lot of calculations in it. Yeah. Okay. So WP5 is clear. Okay. WP6 is extent of stakeholder involvement and level of conflicting requirements. What does it mean? CP must be constrained by stakeholder. For example, the product is in approach of children, so safety issues needs to be added in design. Okay, so the added design constraints are not essentially the requirement of the product, but added only due to the safety, ease of use, and well-being of the end user. So maybe something can be designed in a different way, but now you are also looking into account that who is the end user. Okay, and considering the end user requirements, you modify your design. Considering the end user is the stakeholder. So considering the end user requirements, you modify your design and you justify your modifications. So if this is the situation that arises in your complex engineering problem where you have to take into account the end user, its safety, its ease of use, and well-being, okay, then WP6 is there in that complex engineering problem.
In this case, you are actually involved with the stakeholders to identify the new based on this literature.
Based on this literature, you don't need to specify, you don't need to actually include the stakeholder into it, but based on the literature, you need to have an evidence. Okay, from the literature. Okay, whatever the reason. Yes, it will come under the category of WK6. So this is again, I will give you the example of that mosquito racket. You see, there are two nets, front and back. Why? So that somebody might not touch and hurt himself, because there is voltage, there is current inside. Okay, so that net front and back is not needed in the actual design, but it's because of the safety of the end user. They have to. So similarly, for example, you have pedestal fans. Now they are there in the approach of children and any common people. So you see there is a net, or there is a cage which is there to protect you so that you accidentally does not hit the fan and hurt yourself. Okay, so that is actually not part of the design. This is actually part of the stakeholder requirement. Okay, so wherever you embed something in the design, you have to embed something in the design because of the stakeholder. Okay, so the design of parameter will definitely be changed because of including that. Okay, so that means WP6 is there in your complex engineering problem. Yeah. You can say it's safety. That's why it comes safety, ease of use. Okay, well-being. So whatever you are changing the design just because of the end user. So whenever you have a situation that even without that you can complete your problem, you can solve the problem, but for the ease of use of the end user, you have to modify your design. So that modification is just justified by WP. Practical, yes, practical. That is product, yes. WP, sir. Yes. That comes under the category of WP6. WP6. Okay, is it clear? WP6 as complex engineering problem attribute. Okay. Now come over to WP7. WP7 says interdependence. Okay, so CEP should be composed of different design elements that are interdependent on each other. Changing one parameter such as material selection would directly affect all other parameters. The interdependence could be between material selection, mechanical structure, electrical design, thermal design, controls and automation. Now, the thing is that this WP7, I was getting confused with WP2, where in WP2 you should have the case where conflicting requirements are there. Okay, so when I look a little deep, okay, what I realize is that they are mentioning the cases where you have to include not just the knowledge of that specific course, but the knowledge of the previous courses into it as well. So like, for example, you are designing something where you need to do the thermal analysis as well, okay, some statics or dynamics analysis as well. Now, this is not the course of thermodynamics, or this is not the course of dynamics or statics, okay? But you have to include that analysis in it because they are interdependent over the complete design of your of the product. So interdependence is there between different classification of knowledge. Okay, thermal, mechanical, electrical controls. Okay. Okay, so the thing is that this is the difference between WP7 and WP2. In WP2, you can remain in the same course, okay, and you can have conflicting requirements within that course. Okay, but when we talk about WP7, so you have to be like inter different courses. So you can have different classification of knowledge, and you include all together. Okay, so if you change one thing, the other things are going to be affected. Yeah, so for example, you are now giving a project to the students where they have to design something, and the design includes a mechanical structure as well. The design includes some thermal aspects as well. The design includes some controls and automation as well. Maybe your course is not of control and automation. Your course is not of mechanical structure design. Your course is not of thermal elements. Your course is something else. Okay, but these are the courses the students have already gone through previously. Okay, so these are the courses students have gone through previously, but they have to include the knowledge from those courses in your design as well. And so that knowledge is going to be affected by whatever the design that the students are making. So things are interdependent. Whatever the design they choose, correspondingly, the mechanical structure design will be there. Dynamics as well. They have to consider mechanical elements as well, automation as well, all these things there. So even if there are two interdependencies are there, more than enough. You don't need to have interdependency of each and everything. Just two interdependencies are there, that is enough. And that could be shown that, okay, this was the mechanical design and this was the electrical design, and this is the course of electrical design something. Okay, but the mechanical design was a prerequisite of this, and the student have gone through it, and now student is showing that calculation in the design along with the electrical design, and how this is how the link is there. Okay. Yeah, but there is one problem in it, because the complex engineering problem will be issued or offered in one specific course. But in the report, then the previous course reports should be embedded into it as well. I mean, that should be present. So for example, if the student in the report does not show the calculations which was done before in the previous courses, if he show those calculations, that's okay. Okay, so the interdependence should be there within the report, okay, of that specific course. The student should be able to correlate different courses in one project. Yeah. Okay. So this is WP. Yes. WP2 could be, no, it's not automatically there. WP2 could be there, could not be there. Conflicting, WP2 is the conflicting requirements in that course.
It is depends upon the material selection. You talk about the whole
Okay, I placed material selection in WP2, but that's what, this is what I placed. It does not specifically mean the material selection. The idea is that WP2 is related to that course, the course which you are teaching. Okay, and in that course, you can have a problem where conflicting requirements could be there and multiple solutions could be achieved, approached. Okay, and WP7 is that the student need to interrelate or relate that knowledge with the knowledge of the previous courses and relate them, they show the interdependency. Okay. This is what I have understood from whatever the material was there on the internet. Okay, and I can be right and I could be wrong. Okay, so so this is the thing. I'm not the one who is making this thing. I'm just understanding the whatever is there. Okay, so it's an open discussion. You're free to you're free to criticize. This is the reason where I sent the presentation earlier, that you are free to criticize and anything, and we can have an open discussion. Maybe I learn from you. Okay. So far, it's okay. WP5. Extent of applicable codes. Okay. Now look, the WK5, P5, what I understand is that it should be applied for the courses where WK6 engineering practice is involved. So you have a course where you are making the students to go through the engineering practice and the codes for designing something, but you are giving a problem in complex engineering problem that does not come under the umbrella of engineering codes available. So they have to go through the step-by-step calculations without just looking at the engineering code and practice and the yes, yeah. Yeah, you have to avoid. Okay, so if you are giving student a problem where they cannot just directly take the engineering code and practice and apply it in their problem, they have to go through step-by-step solution themselves. This is WP5. Calculation is covering. Now this is not calculation. This is the justification. I will come. There is a very important slide here. After this, I will come to that, and that's going to answer. Yes, namas. Right. Okay, so we discussed about complex engineering problem attributes. WP 1, 2, 3, 4, 5, 6, 7. Okay. Yes, it's start. Okay, now this is very important, that in complex engineering problem there should be rationalize, reason, and justify. Okay, so in complex engineering problem there are large number of calculations with a lot of variables of the problem, but along with that students are required to do critical thinking in order to rationalize their selection, reason their assumption, and justify their solution. A CEP without rationalization, reasoning, and justification is incomplete. So if somebody thinks that, okay, he did all the calculations, but there was no reasoning given, okay, there are a lot of issues where the reasoning or justification is needed, why you selected this thing, why you did not go for that selection. Okay. Now, the thing is that there is no right or wrong answer. It's like, for example, if I go to buy a mobile, okay, so in the market there's mobile of Samsung, there's mobile of iPhone, there's mobile of Xiaomi, Redmi, there different mobiles are there, okay, and I have to look at the mobile parameters and what are my needs. Whatever the mobile I select, it's not a wrong there is no wrong answer, but I need to have a reason for the selection. Okay, maybe I'm looking for a larger battery size. Maybe I take a lot of pictures and make videos, so I need a good camera. So I'm looking for a mobile with good camera. Maybe I'm looking for a mobile which is a bit robust. That maybe I'm working in a site and there are chances that my mobile be broken. Or maybe I'm looking for a mobile which has dust and water protection. Okay, maybe I'm looking for a mobile. I play a lot of video games which has a good processing capability. Okay, so there are different parameters available in the market and there is no right or wrong answer. This is a reason. The thing is that whenever the students will be making any specific selection or making any assumption or making or developing a solution, okay, they have to justify, reason and rationalize. Okay, and it should be there in the student report. So suppose if the student did not rationalize its selection, you have the right to deduct the marks that, okay, the student did this selection. I'm not saying that the selection is wrong, but the student should rationalize why he selected this thing. There were other options as well. Okay, so in complex engineering problem, the major part is rationalize, reason and justify. Without that, just calculations will not be enough. Okay, so this is an important point. Now, expectations from the student. Okay, let's say that I want to give a complex engineering problem to the students in my course. Okay, now I have to tell the students that what are the complex problem solving attribute that I'm targeting and what is expected from the student.
Maybe I can also put whatever based on this quotation, I can choose which attribute other than the keyword would be part of the
Yes, that's true. This exactly, this will help you. But the point is that a student should be clear as well that what we are looking for. The student should not be blindsided that, okay, they have a CEP complex engineering problem, they solve it, and in the end we grade them that, okay, you did not come up to the expectation. So say, I do not know what I had to do. Okay, so the student should be very clear that what are our expectations from the student. Okay, so suppose when we are saying WP1, students should be able to show all the calculations for the solution of CEP. Students should be very clear that if they provide a report of CEP without calculations, WP1 is not satisfied. Okay, when we say WP2, range of conflicting requirements, students should outline all the conflicting requirements, rationalizing their selection in the report. Achha, what I suggest is that we ask the students to solve the problem, then make a special heading mentioning that what were the instances where the student had conflicting issues and they selected one, and what was the reason for that selection. So make this as a separate heading. Because I am targeting WP2 in my CEP, so I want to assess the student in that WP2. So it is part of the overall calculation, but there should be a separate heading where whatever the instances were there, where the student had conflicting options and they selected for one, they should specify that what were the conflicting options. Okay, why did they selected this one? Okay, and how do they rationalize their selection?
These were most of that we are part of that. I mean, whenever I open it up, they are are there.
Yeah, WP4 might be there, might not be there, because WP4 is something very, very new. It's not there at all in the market, in the literature, in anywhere. Okay, so WP4, you made a problem on your own. Okay, so it not necessarily be a problem which is there in the literature. Literature means anything: paper, textbook, reference material, internet, Google, wherever they can search. If it is not reported, then it is something that is unfamiliar. Student cannot get the solution of it directly. Okay, so coming over to WP1, student should show all the calculator. For WP2, student should outline, okay, all the conflicting requirements, rationalizing their selection in the report, wherever they had to make the selection. And this is what my suggestion is, that when the student write the report, if I am targeting WP2, the report should be there throughout by all the calculations and everything there. But after the report, there should be a separate heading regarding WP2, and where they should specify what were the instances where the student had to make a selection and there were conflicting issues. Okay, and so that become a separate heading, that becomes a separate topic that you assess, and you can simply say that, okay, because this is there, so now I am assessing that the student have fulfilled the WP2 requirement. Okay, WP3, depth of analysis required. Students should discuss the range of solutions possible for given CP and justify their proposed solution. Okay, so for WP3, as I told you, there should not be a singular solution, singular. So there could be multiple options, multiple solutions. Okay, so the student should say that, okay, I could have taken this thing and my solution could have come this thing, or I could have taken this thing and solution would come like this. So there were multiple options. I selected this option because this, whatever. Okay, again, there is no right or wrong answer. It's just their rationalizing and reasoning is important in complex engineering problem. Okay. Then WP4, familiarity of issues. Students should discuss what kind of issues are available in literature, emphasizing that their solution is unique and not copied from literature. I mean, you have given a problem, and the student, if we are targeting WP4, so I said that make a student in their report, make a specific heading that this problem is not there in the literature throughout. Similar problems like this were there. Whatever the kind of problems are there, they can discuss that, and they should mention that, okay, but this specific problem was not there. But like the way we do it in literature review, the idea is that when we are doing literature review, what we are saying is that our research is not there in the literature. The things from here, there, sideways, all things are there. Okay, but that specific thing which we want to do is not there. So when we are putting familiarity of issues, when we are putting up a problem to the student which is not there, which is our self-made problem, they won't be able to find it anywhere. So they can just do a little literature search of that and say that, okay, this kind of problem solution is not there and we are doing it on our own. Okay, this way we can actually justify. Now, this is all my intuition, which I am imparting here to you. It's not written anywhere in any document that it should be like this. So this is all my intuition, but this way justifying it to the evaluator will be easy. That, okay, because the thing is that whenever you place any complex problem solving attribute in your CEP, you have to justify its assessment. How did you justify? Okay, how did you say that, okay, this attribute has been taken into consideration? It's not like, okay, I placed this attribute in my CEP. No, you have to justify its assessment. How do you justify that this attribute has been actually covered by the student, and you pass him in that attribute, or you fail him in that attribute, or whatever the grade you want to give him in that attribute? Okay, so that justification could be done in the form of a report. Within the report, you can have a separate heading where you mention, you ask the students to mention that, okay, they have to show that in literature search, they do not find anything related to it. Exactly that thing. Okay, so they have to do all the solution by themselves. Okay, WP4 is clear. This slide is basically what should be the expectations from the student, and the student should know. Student should be predefined that, okay, we are giving you a complex engineering problem and we are targeting these WPs, and this is expected from you, that how do you respond it in your report. Okay, Then WP5 is extent of applicable codes. If there are standard engineering codes and practices available, the student should elaborate that given CEP could not be solved using the standards, justifying that the step-by-step calculation was a necessity to solve given CEP. Again, if we are putting WP5 in the CEP, so in the report of WP of that CEP, there should be a separate heading, and that separate heading, student need to just discuss on it on his terms that okay, this is the problem. The standard codes could not solve this problem. Standard practice could not have a solution of it. Okay, because we have to specify what are the standard codes of practice available, and this problem is beyond that range. So we has to mention the range and mention that okay, this problem is beyond that range and it's not there in the standard practice. So that's why we are doing the, I'm showing you all the step-by-step calculations. Okay, so if the student have actually justified that, elaborated that, I have put the words in red here just to mention that the rationalized justification and reasoning is there by the students. Okay, the WP5 is clear. Okay, then we come to WP6, extent of stakeholder involvement and level of conflicting requirements. The student should specify separately what constraints have been added in the solution due to the safety, ease of use, and well-being of the end user. Student should mention that, okay, this problem could be solved without it, but I had to add it because of the end user, because of the stakeholder. Okay, so this should be placed as a separate heading in the form of a discussion that would actually surface, that would actually support the grading and assessment of that WP for that complex engineering problem. Clear? The last is interdependence. Students should highlight the interdependence of various solution modules for given CEP. So they should mention, now this, how they should mention, it could be in the form of a discussion or maybe in the form of a block diagram, which says that, okay, we have this electronic design, which is actually dependent over the electrical design, which is actually dependent over the mechanical design, which is actually dependent over the thermal design. And so they mentioned that, okay, if change one thing is going to affect the change, is going to affect the other thing. So all the other designs are interdependent. So they have to show the interdependence, whether in the form of a block diagram in the discussion, the way it is suitable for your project. Okay, but that would actually be necessary so that you can, when you assess them, when you grade them, so you have a reason behind that. Okay, this is the reason why I graded this attribute, and say that, okay, the student have justified, satisfied this attribute. So these are the expectations from the students that the students should know by the time we are actually giving the CEP to the students. Is it clear? This was the topic about, okay. Okay, talking about placement. Now, this is my opinion. Okay, given the nature of CEP problems, my opinion is that it should be placed in the theory courses rather than labs. Now, this is my opinion. And again, I could be wrong, okay? Because in theory courses, most of the time we are going through a set of calculations. All the attributes that you have gone through, actually the theory courses are the ones where we are actually going through these attributes rather than the labs. Labs in generally, by sense, every week that there is a set of experiments that the students perform as they come to the labs, okay? And they are predefined experiments. So we can have open-ended labs, okay? Now here, if placed in labs, the CEP might involve psychomotor content in it and can be called as open-ended labs. I could not find any other difference between CEP and open-ended labs in the literature. I tried to find the difference between open-ended labs and CEP, but I couldn't find anywhere in the literature where it specifically say that this is CEP and this is open-ended lab. No, this is my perception. Again, I might be wrong here because there was no.
So what is the problem of the class? They will build confidence, then they will go to So that is what operate problem, so we can operate in that, because it is something we have. So that's why we can operate.
But anyways, when I searched over the internet, I couldn't find any specific definition or difference between CEP and open-ended lab. Okay, so this is the thing. So I put my perception here, but I'm not pretty sure whether this perception is correct or not. Okay, however, the complex problem solving attributes, WPs, would remain the same in open-ended lab as in CEP. Whether we are putting open-ended lab or we are putting complex engineering problem, the WPs, complex engineering problem attributes, they must be same. And they must be satisfied. Okay. Now, this is a Karachi-based university. I'm not going to take the name of the university, but this is a Karachi-based university offering mechatronics engineering program. The BE curriculum of Karachi-based university offering mechatronics program reports CEP in assignments of overall 5% overall marks in the following theory courses. Now, what they have done is in their theory courses within the assignment, 5% marks were assigned for complex engineering problems. And what were the courses where the complex engineering problems are reported? And in that is statics, dynamics, mechanics of material, fluid mechanics, fundamentals of thermal sciences, machine design, mechatronic system design, digital logic design, signals and systems, electronic circuit design, instrumentation and measurement, linear control system, sensors and actuators, introduction to robotics, industrial control and automation. These were the courses where theory courses, not the lab, theory courses where they employed complex engineering problem in assignments, 5% mark of overall out of 100. Okay. So these are all the courses which are there are courses for WK3, WK4, and also I think WK5 is also there, and 5 and 6.
After this, we can also change some examples which are available online. We people have assigned 3 people different courses. Now, when we get a course, they will be assistant to give presentation or they will be central how it should be. We have answer.
Okay, so this is I gave to you as an example because I got the information. So we'll discuss later. Okay, CP. Now this is my perception again. CP statement requirement. Now we are giving complex engineering problem to students. What are the things that should be there in that statement which we provide to the students? The first thing, CEP is suggested to be linked to a CLO. If you are giving a CEP to the students, then in that paper, where you are specifying you're explaining your CEP, you're giving it to the students. The first thing is that it should be linked to a CLO of that course, definitely. Okay. And the target CLO should be of highest taxonomy level. The one with the CLO with the highest taxonomy level that should be targeted. Okay, if there is a design factor there and there is a basic knowledge, basic engineering knowledge is also there in it, then we will target for the design. Okay, if there are engineering codes there, we will target for the engineering code. Okay, that should be the CLO. Then total marks of CEP should be mentioned to the students. Okay, we are giving you the CEP, complex engineering problem. These are the total number of marks for this out of 100. The student should know. A well-defined statement should be provided along with the problem scenario, constraints, and solution acceptability terms if present. So you want to put some constraints, you want to define some solution acceptability terms, okay? Because this is kind of an open-ended most of the time. The students have multiple options to go for the solution. Okay, but there have to be some definition of the problem of what we are giving to the students. The course by course, obviously, is going to vary. Okay, so a well-defined complex engineering problem statement should be provided along with the problem scenario, constraints, and solution acceptability terms if present. Okay, then the fourth thing is a table showing grade distribution of the WPs desired in given COP. So let's say I give them the COP of 20 marks. So I should mention that it is targeting WP1, let's say WP2 and WP6. And I should mention that out of these 20 marks, 10 marks will be for WP1, and then 5 marks will be for WP2, and then 6 marks is for WP6. I'm just giving an example, okay? And in this table, that when the students are going to get the marks, you can just write that what are the marks obtained by the student, so that each complex problem solving attribute is taken into account for grading. Okay, so this is a problem that we say that we are placing this attribute in CEP, but the evaluator is going to say that how did you grade it, based on how much? Okay, what was the percentage of the grading of this attribute in complex engineering problems? So it should be specified. This is the thing. Okay, then this is the fourth thing. The fifth thing is a statement for each WP in the given CEP mentioning what is expected from the students against each in the report. If I'm saying WP1, WP2, and WP6, then I need to have a statement for WP1 mentioning what I am expecting from students from WP1. Then from WP2, I should mention what I am expecting from students from WP2, because they will be graded out of that. Okay, they will be assessed against that WP2. So I should tell the students what I'm expecting from them. Then if WP6 is there, then I should also mention that, okay, from WP6, this is I'm expecting in the report from you. Okay. Then finally, a rubric for the assessment of each WP should be given. Okay, the student, it's better that the student already have the rubric with them, that, okay, this is the rubric based on which I will be tested, I will be graded. Okay, so that maybe the student can work better and the student can actually aim for the higher grade. Okay, rather than saying that I didn't knew that if I have done that, I would get this mark. Okay, so if the rubric is there in front of the student, that is better. Okay, the students should be mentioned that they should separately address each WP in the report for securing marks. Students should address each WP in their report, not just doing one set of calculation and send the report. Okay, now you find yourself, where is this WP? Okay, no, not like that. Okay, do this and then give a separate heading for this WP. Write down what were the parameters that you have taken into account in order to address this WP. Okay, in this way you can directly assess them. You can see the calculation. You can assess the WP as well based on their rationalization. And here, when they have to address a WP, rationalize, reason, and justify. This is important. Without that, incomplete. Maybe you did all the right calculations, but if you did not justify your selection, if you did not rationalize your selection, then random selection is not accepted. You need to have a reason. Why did you select this thing? You had 4, 5, 6, 7 options in front of you. You selected one. Okay, no, there is no right or wrong answer, but you need to have a reason for selection. Okay, so students should be now. What I feel is that if we have these 6 things, then our problem statement is complete for the complex engineering problem to be provided to the students. Okay. Now, again, this is not a format provided anywhere. I just made myself thinking that what should be there that would make it easy for the evaluators to look whether we have included that attribute in complex engineering problem, which we are claiming to be there in that complex engineering problem or not. Okay. Again, this is my perception based on that. You have the complete authority to change the way you like. But if you have anything, you can obviously come and discuss. We have discussed together. Okay. This was one of the complex engineering problems that I get from internet. This is not a very good one, but anyways, I mean, this is not very clear picture, but this was the statement mentioned. Then they were mentioned that what is asked from the students, okay, in this problem. Then they have specifically mentioned that WP3 is used, WP1 and WP2, and then from WP2, what is asked from the student, with WP1, what is asked from the student. They have mentioned it. Then they have mentioned it that CLO3 is targeted for this. Okay, and they are also using EA1 and EA4, but it is not needed that we mentioned that we are using which engineering activity. It's not needed. And then they have also provided, this rubric is not complete. I guess this rubric is not complete because when you want to provide rubric, you have to at least give 4 or 5 set of different evaluation criteria, okay, for that rubric. But anyways, as an example, I have added this. So just, so the statement problem would be like 2-3 pages. And this is the reason why I say that although PEC does not specify that how many WPs you should add in your CEP, but keep it as minimum as possible because it's not just adding it. You have to justify its assessment. You have to justify its assessment. You have to mention that what was needed from the student in that WP, how the student have responded to it, what was the rubric assigned, what was the grade, on what basis you have decided that the student should be graded according to that rubric, okay? I mean, a lot of justification and paperwork increases on your part if you increase the number of WPs in your CEP. So it's not just adding as many as you want, okay? It's the justification is important because this is the place where we are going to get in trouble with the evaluators, okay? The last thing is that this is again my perception. It's not needed. It's not said by the PEC that they should be, but we should have a table which mentions that what are the courses where we are using CEP. Okay, then among those courses from WP1 till WP7, okay, what are the attributes that we are targeting? Okay, and then eventually we have to see that total frequency of each attribute, because I think, again, it is not mentioned by PEC, but I think it will be a problem later on if there is a specific attribute that we did not target in any course at all. Let's say we are not targeting WP. So the faculty have the right to decide which WP he want to choose in their CEP, but then the administration and the HOD and the PM have the right to ask the faculty to include this specific WP as well in your CEP, because we had to include it in the entire program. Okay, now this is my perception. There is no there is no such requirement mentioned by PEC, but I think later on it will become eventually. So this was the complete presentation which I had prepared, and if anybody want to discuss anything or